You are welcome to Chemistry for Starters. We'll be considering chemistry for starters. Chemistry may be defined as a science that is concerned with the composition and structure of matter and with the forces that hold the structure together. Now, understand what I'm saying, that it is a study or the science that is only concerned with the composition. What are those things that are made up of, that are contained in a particular substance, composition of substance, of its matter, and the forces that hold the structures together. That's forces that hold the materials together. So these are the things that we shall be considering in chemistry. The composition of matter and the forces that hold the matter together to make it a structure. And chemistry is a science and has its primary objectives, which is the determination of the nature and property of non-living matters. That is the objective of chemistry, the determination of the nature and properties of the non-living matters. Now we'll be looking to some things that we do at home that are basically chemistry in nature. 1. Chemistry in our lives. There are a lot of chemical changes around us at all times. There are a lot of chemistry around us, chemical changes around us, and at all times. Some of the things that we do that are chemical changes are as follows. Cooking, all manners of cooking, lighting of match, burning firewood, rusting nails, rotting leaves, making of palm wine, manufacturing of drugs, all the things we use every day, such as soap and detergents, hair cream and perfume, oil and margarine, plastic and made through chemical processes. So many things, almost everything, if not 90% of what we use on a daily basis are basically chemical, are made through chemical processes. Now let's look at scientific methods. Chemistry and other fields of science have developed through a series of discoveries. I repeat, chemistry and other fields of science have developed through a series of discoveries. They use their senses to observe what is happening around them, and through observation, they see a certain pattern which often leads to a problem they try to solve. Now, we will be considering two important things now, if not three. The first one is the term called hypothesis. Another one is what we call theory. And the third one is a scientific law. Scientific law. What is an hypothesis? An hypothesis is an idea that is suggested by a scientist that has not been confirmed to be true by other scientists. I repeat, hypothesis is an idea or a suggestion or observation that has been suggested by a fellow scientist that other scientists have not actually confirmed as true or as real. Now, what is theory? Theory is that fact suggested by a scientist that other scientists have confirmed to be true. So when your suggestion, your idea has been confirmed by other scientists to be true, it becomes theory. Now, what then is scientific law or principle? Scientific law or principle is established only after the theory has been extensively tested and proven true without any exception. So when a theory has been extensively tested and proven to be true without any exception, it becomes scientific law or principles. Chemistry is very useful in many aspects. So just quickly mention some aspects where chemistry is of great importance. The study or knowledge of chemistry has contributed greatly towards providing our basic need and improving the quality of our lives. I repeat, the study or knowledge of chemistry has contributed greatly towards providing our basic need and improving the quality of our lives. This includes food. In the production of our food, The farmer uses fertilizer, insecticide, pesticide, and all these things are product of chemistry. Clothing. Through intensive chemical research, man-made textile fibers are produced that we use as clothing. Military. The duty of the military is to defend the territorial integrity of a nation, and this is provided through the production of ammunition, which also have the support of science or chemistry. Space science. In our effort to gain knowledge of the things happening in other planets, our outer space around us, special rockets called space rockets are sent into space, and we build all these rockets through the knowledge of science. Housing. To overcome the present need for housing and maximize use of land space, especially in cities. This building needs material like cement, concrete, steel, bricks, and tiles. All these are produced in chemical industries. Medicine. Health, as we know, is wealth. The health life that many people enjoy is due to the variety of medicine that are available. And all this is also produced through the knowledge of science and basically chemistry. Transportation. Modern transportation system is an essential feature of today's world. And all these beautiful cars, ideas are produced through the knowledge of science. Now, we have looked at the beneficial aspect of chemistry. Now, let's look at the adverse effect of chemistry. 1. Chemical processes and products also have negative or adverse effects on our daily lives. 1. Corrosion of ions. Corrosion or rusting of iron occur when iron is exposed to water and air. And this corrosion can be regarded to be a very slow deterioration of iron sheets. But this can be prevented. We can prevent rusting by application of protective coating, application of sacrificial metals, cathodic protection, galvanizing, oiling, and greasing. These are a few ways of preventing rusting. Another problem again is pollution. One of the main adverse effects of chemical industries is the pollution of our environment. Water pollution, air pollution, and many others due to processes of or chemical processes that leads to the production of all these waste materials into the atmosphere, or the release of this material into the atmosphere. For instance, oil spillage, pesticide, fertilizer, and acid rain have made our environment unclean. And the last one we're looking on that note is drug abuse. Drug abuse has contributed greatly to the problem of the world. Drugs that are not being, using of drug that is not prescribed by doctors it's what we mean by drug abuse. When you use drug that is not prescribed to you by doctors, it's called drug abuse. You are abusing that drug. So we have series of our young ones today that are into drug addiction. So this is a present threat to the world as a whole today. So this must be checked. So still on drug abuse and drug addiction are major problems in our society today, especially among the young ones. Drugs that are abused are heroin, cocaine, morphine. These drugs are not used for medical treatment. Rather, they are addictive, and some bad people in society produce and sell them to make huge profits. Many countries have imposed strict law to control pollution and drug abuse. But the most effective control means is education. So that's the only way when our young ones are educated on the adverse effect of this drug in their system. So it can be checked and can be corrected. Now let's continue by looking at matter and separation techniques. Matter and separation techniques. Like we have defined it in our elementary class, that matter is anything that has weight and occupies space. It's as simple as that. So we're building on that knowledge that we have in our little elementary class. So we're building on it. We'll go a bit further. So that same matter we're looking at it from other perspective. Now, look at what we call a mixture. A mixture may either be homogeneous or heterogeneous. A mixture can either be homogeneous or heterogeneous. So, like we know that when you dissolve a substance in water, and if that substance dissolves completely in water without sediments or without settling, we call such an homogeneous solution. But when there's sediments or settling at the bottom, or when it exists in two phases, that is, we have the liquid and the solid phase, we call such an heterogeneous mixture. I repeat, an homogeneous mixture are called solution, and they exist in single phase. That is, the substance dissolves completely in that liquid. The solute dissolves in the solvent completely. But when there is settlement, or when it exists in two phases, like this, we have the liquid part and we have the solid part, we call that an heterogeneous mixture. That will take us to the next thing, element and compound. An element is a pure substance that cannot be decomposed into any simpler pure substance. I repeat, an element is a pure substance that cannot be decomposed into any simpler pure substance. A compound is thereby, this is a pure substance that is composed of two or more elements in a fixed and definite proportion. So that is when they are mixed together and they combine chemically, when substance or element combine chemically together, we have what we call a compound is formed. Types of changes. Types of changes. We have two basic types of changes, physical change and chemical change. Physical change and chemical change. A physical change is one which is easily reversed and produce no new substance. Example, the dissolution of common salt in water is a physical change because no new substance is formed, and the salt can be recovered by evaporation or by evaporating the solution to dryness. And many others. Changes in states, such as melting of a solid, the liquefaction of gas to liquid, the freezing and vaporization of a liquid, as well as changes in shapes, are examples of physical change. Physical means such as filtration, evaporation, distillation, sublimation, and crystallization may be used to separate the component of a mixture. I said that physical change are those changes that are reversible, and no new substance is formed, and it's not accompanied by it, and there's no change in mass. Those are physical change, and we've listed example of such, that dissolution of common salt in water, which can easily be recovered. So, and all the chemical, probably let's say some of the separation techniques like filtration, evaporation, distillation, sublimation, all these are examples of physical change. Another example of physical change is the magnetization and demagnetization of iron rods. Now let's go to chemical change. Chemical change is the transformation in which a new substance is formed and is not easily reversible. Physical means cannot be used to separate the components. So we cannot separate the component by physical means. Example is burning of substance. All forms of burning of substance. Addition of water to calcium oxide. Burning of magnesium ribbon in Bunsen burner or Bunsen flame. Roasting of iron. Reaction of metals and calcium trioxocarbonate with dilute acid. All these are simply chemical processes or chemical change. Now, let me summarize it now. Physical change has the following features. It is easily reversible. An example is all cases of vaporization of liquid. 2, it produces no new substance, e.g. all cases of melting of solid to liquid. 3, there is no change in the mass of substance involved, e.g. magnetization of iron. And 4, it does not involve any great heat change except latent heat change, which occur during change of states. Then chemical change has the following characteristics. It is not easily reversible, e.g. all cases of burning. New substances are produced, like the case of roasting of iron. There is change in the mass of substance involved. Example is slaking of lime. And a considerable amount of heat change is involved. Example is explosion of coal gas or hydrogen with air. So these are some of the similarities and the difference between physical change and chemical change. Now let me summarize element properties and examples. Elements are good conductor of electricity, for example like iron, tin, lead, zinc. Metalloids are semiconductors of electricity like silicon, boron, arsenic. Non-metals that are non-conductors of electricity like oxygen, chlorine, hydrogen, argon, bromine. I repeat, metals are good conductors of electricity like iron, tin, and lead and zinc. Metalloids are semiconductors of electricity like boron, arsenic, and silicon. While non-metals are non-conductors of electricity. We have things like oxygen, chlorine, hydrogen, and so on. Now let's make a comparison between metals and non-metals. Just a few of them anyway. All metals except mercury are generally solid under ordinary conditions. So they are solid except mercury. Metals have high melting point and boiling points. Metals are good conductors of electricity and heat. Metals are malleable, that is, can be hammered into different shapes, and are ductile, that is, can be drawn into thin wire. They possess characteristic luxury. They exist as crystal lattice held by strong metallic bonds. So the bonds is very strong that held them together. Now let's go a bit further on the definition of mixture. A mixture is a substance formed when two or more constituents are physically joined together, or when two or more materials are physically joined together. The constituent of mixture can be element or compound or both, and can be separated by physical means. Example of a mixture is air, that is made up of oxygen, carbon dioxide, nitrogen, rare gases, dust, and moisture. Another example of mixture is soil, made up of sand, clay, humus, water, air, and mineral salts. So these are examples of mixture. Now let's go to compound. A compound is a substance formed when two or more elements are chemically joined together. A compound is formed as a result of chemical change, and it is a new substance with different properties from the substance. Example of compound is water, H2O, and the component element is hydrogen and oxygen. Then another one is sodium hydroxide, which contains sodium, oxygen, and hydrogen. Another one is sodium chloride, which contains elements sodium and chlorine. Another one is glucose, C6H12O6, which contains carbon, hydrogen, and oxygen. So these are a few examples. Now let's conclude by looking at the difference between mixture and compound as we close on this part 1. Mixture has the following characteristics. It may be homogeneous or heterogeneous. The constituents or the material are not chemically bound together and can be easily separated by physical means. The constituents can be together in any ratio by mass, hence a mixture cannot be represented by a chemical formula. The properties of mixture are the sum of those of its individual constituents. Mixture is not usually accompanied by external effects such as explosion, evolution of heat, or volume change. Now, the compound has the following characteristics. It is always homogeneous. The component elements are chemically bound together and cannot be separated by physical means. 3. The component elements are present in a fixed ratio by mass, hence a compound can be represented by a chemical formula. Number 4. The properties of a compound differ entirely from those of its component elements and usually accompanied by one or more of these effects. So this is the first part of this chemistry for starters. So I'll appreciate if you can click on like, pass your comments and subscribe to this information. Thank you. See you in the next edition. Thank you.